Hi, welcome to this video in which we will explore how nanotechnology is positively impacting solar cell development. On this channel, Synergy Files, we aim to inspire budding engineers and technicians for a better, more sustainable world. Subscribe to the channel today to get the updates of our latest videos. Before we begin to explore how nanotechnology is boosting solar industry, we must learn what is nanotechnology. Definitions of nanotechnology are wide-ranging, but perhaps the easiest to comprehend is that nanotechnology refers to the manipulation of matter with at least one dimension size from 1 to 100 nanometers. We have observed that as we purify and strip down materials into smallest of scales, then these materials depict remarkable properties that cannot be observed in their scaled up and crude versions. We have noticed super strength, very high electric and thermal conductivity, and even transparency in the tiniest pieces of the same material that are otherwise absent in their macro scale counterparts. Graphene is a classic example. At a macroscopic level, it can be a chunk of carbon like graphite, as in the pencil lead. Peel it down to a single layer and it becomes a wonder material. Nanotechnology has made its mark on the aviation industry. It has helped us in making aircraft that can travel further, and now it's helping us getting the most out of solar energy. A good example of this is dye-sensitized solar cells, or DSSC. Through nanotechnology, we have been able to make solar cells that mimic the way plants harness energy, that is photosynthesis. There are quite a few advantages of DSSC. They can be made semi-transparent, they can be made flexible, and can also harness more sun rays when there is a greater cloud cover. Another example of the use of nanotechnology in solar application is the research going on in Kyoto University. They've developed a silicon-based nano semiconductor which can harness more wavelengths from the spectrum of solar light energy. The way it achieves this is through etching silicon layers to have a large number of identical and equivalently spaced rods, the height and radii of spacing of which was optimized for the target bandwidth. This allows more of the light to be reabsorbed by silicon to excite the electrons, then to be converted as heat. Using this material, the team has shown that their nanoscale semiconductor raises the energy conversion rate of solar cells to at least 40%. Similarly, using nanotechnology, coatings have been developed for solar thermal applications that do the opposite. That is, they capture the sun rays and effectively convert them into heat. Lastly, we have also explained in a previous video the research that is being carried out on the use of graphene in solar panels in 3 different ways. The most likely technology that will materialize in the near future is the use of graphene as a charge carrier in solar panels. So that concludes the video. We have some links in the description section for you to explore more about the technological developments in this area. If you like the video, do give it a thumbs up. Thank you for your attention.